We're going to look at solving another quadratic equation, f of x equals x squared plus 2x plus 3. And we're going to once again use the quadratic formula. And in this case, this one's different. Notice I've already told you that we're going to have two complex solutions. And what that means is we're going to be looking at complex numbers this time instead of a real number like we've looked at before. Actually, a complex number means that it has a negative under the radical, or a negative square root. So remember, we always start out with standard form of ax squared plus bx plus c, where a is my leading coefficient, b is my secondary coefficient, and c is my constant term. So my first step always is identifying a, b, and c. So a is going to equal, in this case, 1. B is going to be equal to 2, and C is equal to 3. Very important that I identify those coefficients and the constant. All right, my second step is going to be substituting. So I'm going to take the numbers I got in the first step, and I'm going to substitute back into the quadratic formula. So I have x equals a negative, in this case b was 2, so a negative 2 plus or minus. Remember, with a quadratic I always have two solutions. The square root of b squared, b was 2, so 2 squared, minus 4 times a times c, which is 3, and that's all divided by 2 times 1. All right, now we go to our third step. Our third step, step number 3, is simplifying. I want to simplify this quadratic equation or quadratic formula that I have substitute the values in. So I have x equals negative 2 plus or minus the square root of 2 squared is 4. And then notice I have a negative 4 times 1 times 3, which gives me a negative 12. All divided by 2 times 1, which is 2. All right, then I continue to simplify. So I'm going to have x equals a negative 2 plus or minus the square root. Now I'll take care of what's under the radical. I have 4 minus 12. 4 minus 12 is going to give me a negative 8, all divided by 2. Now notice I have a negative under the radical. So that means I'm going to have a complex solution. That's going to give me an imaginary number. So let's go ahead and take care of that. So we're going to deal with the square root of negative 8. Well, I can't take the square root of 8, so first of all, I'll split off the negative from it. So I write it as 8 times a negative 1. And I'm going to split that off into the square root of 8 times the square root of negative 1. Well, if you know anything about complex numbers or imaginary numbers, you know that the square root of negative 1 is defined as I. So we're going to take square root of 8. Can't take square root of 8, so we break 8 into 4 times 2 times I. We're going to substitute in I for square root of negative 1. We can take square root of 4, so square root of 4 is 2. It comes on the outside of the radical, so we have 2 onto the square root of 2, I. So that's how we deal with a negative square root under the radical. Now we're going to substitute it back in. So that's going to give us x equals negative 2 plus or minus 2 onto the square root of 2i, all divided by 2. We're going to separate this out into two solutions. X equals negative 2 plus 2 onto the square root of 2i, all divided by 2. And we can actually simplify that further. Notice the 2 here and here, and it's divided by 2. So 2 will go into 2 one time. 2 will go into this 2 one time. So it's going to give us x equals a negative 1. Once this 1 we don't have to write. So it's plus the square root of 2i, and it canceled out the 2 on the bottom. So there's one solution. The second solution is x equals negative 2 minus 2 on the square root of 2i divided by 2. And remember, we can cancel the 2's out here and here. So x is going to equal negative 1 minus the square root of 2i. Those are our two solutions. Now I want to show you what this looks like graphically. If you look at the graph of this equation, notice before when we checked it, we always looked for where it crosses the x-axis. In this case, it doesn't cross the x-axis anywhere. So therefore, that's always a tip-off to me that it has a complex solution. So anytime you graph a quadratic equation, it does not cross the x-axis, you know you have a complex solution. In order to find that complex solution, you have to use the quadratic formula.